the James Webb Space Telescope is exploring the universe, and it's revealed sights humanity has never seen.
So the goals of the first images were to showcase the impressive capabilities of JWST to the public and to the astronomical community at large. And the subsequent images have been taken more for specific science questions that have been asked by the various groups in the astronomical community. And so those pictures are much more tied to specific science questions, and still they're beautiful. The JWST mission has taken a long time to get here. It's been 25 years in production. And so it's been a lot of effort by a lot of people, including myself, over a decade and a half myself on the mission. And so to actually get to the point where we get to see the pictures, the fruits of all that work, was really, really amazing for me to finally see that come through. And they were just so spectacular. It was excellent. It paid back all that effort and more for me. So for a team of scientists to get time to actually observe with Webb, the first thing they need to do is write a proposal. And so that proposal is a text, but it also comes with on what they want to do, what targets they want to observe, and which instruments they want to use on JWST and which modes. And so then that gets put together and submits here to the Institute, but then the Institute convenes a panel of experts from outside the Institute for all astronomers, and then they get to rank. They look at all the proposals in a specific area and then rank them, and the top ranked proposals then get forwarded to actually take their observations.
When a science team is awarded time to work with Webb, they start by using a special software to set the required parameters for the telescope to conduct their science. The software allows scientists to use different modes on Webb's instruments to achieve their scientific objectives. When it's time for the observation, the code instructs the telescope to locate the target object and capture several images of it. Light from the target object is processed through the instrument, and the raw data the science team requires is stored onto Webb's onboard hard drive. Once the team's data is collected, their data and images are transmitted to Earth from Webb, to NASA's Deep Space Network ground stations, where their data gets routed directly to the Space Telescope Science Institute.
Once we get the data here in Baltimore at the Institute, then we run it through our pipeline that as a series of steps that removes the artifacts from the instrument or the detectors that we know about because we've taken extensive calibration observations. And we now produce these cleaned images that are just about the astrophysical source we're interested in. And then all those images go into an archive here at the Institute that's then available to the proposers that they can then download it and start doing their science on it. So if we're going to produce a color image out of the observations, then we've taken multiple images in different filters, and then those, after they've been processed through and removed all the instrumental artifacts, then we pass them along to the experts in our public outreach office that then turn them into the really sensational color images that we all love.
When you're processing any sort of astronomical image, those images are taken through different filters, so the light's captured through different filters and it starts out grayscale. And then so you actually get color information from taking the light in those filters, and then you assign colors afterwards, like an image processor will assign colors, and we do this typically in what we call chromatic order, which just means that the shortest wavelength gets assigned the blue color, in between is green, and then the longest wavelength gets assigned the red color. And then we additively combine those together to get our full color image.
The reason we want to color the images is because there's actually more that you can get, more information that you can get from the image if you see it in color. If you're looking at a galaxy in optical light, we expect that there are going to be star-forming regions, and they're going to show up as these bright blue regions, and then if there's hydrogen gas around them, that will show up as bright red. And so if we can apply the color to the different filters and make an image in color, you can actually just see that right away, and you learn something new from the image by seeing it in color.
Webb's imagery and science are revolutionary. It's challenging our theories of the universe and generating more questions we need to answer.